Hello, good morning. This is just my setup I have made here to show you polarization in a corrosion cell. So just to know you that the corrosion, how the corrosion takes place. So I have made setup like this. So this is actually we have taken a plastic container and soil is filled here, and there is a steel coated steel rod here, a small coating, say steel rod with coated, and another is your copper. We have taken a copper. So as you know that steel is say anodic to your copper. So the here steel will corrode, and the current will be going through electrolyte from steel to copper and back from copper to steel. So the same setup is there. So this we have taken a resistor 0 to 100 ohms in series with the steel and copper with the switch, and then the ammeter in series to measure the current, corrosion current. And this side I have put two reference cells here. So we will measure the potential of the steel and the copper initially, and then we will have put the resistor, so 100 ohms first, then gradually we will reduce it and to 0 ohm. So we'll give what is the current. Okay, so I will just measure here. So in this case now the switch is off and we have kept it 100 ohm, so it is open circuit potential, you can say. So we'll just check here with the reference cell. So positive terminal is connected to your say this is your reference cell, because reference cell is positive earth, and negative to your say the first we measure the steel. So with the steel it is coming around 372 millivolt. So 372 millivolt is the steel say potential, open side potential, and the copper it is coming around 58 millivolt. Okay, so this is the open circuit potential. As you can see, the steel is more negative than the copper. So it's at the galvanic stage. It is at the say it's at the higher electronegative. So there is a difference between the steel and the copper. That is why the current will flow from steel to copper. Now what we do, we will just make the switch on. This is a switch, so switch on. Now this is come in the circuit. So now the corrosion current will, at the 100 ohm, the corrosion current will start to flow. Okay, and we see that in the series this comes to around 33. It is fluctuating, so it is coming, let us say, stable around 33 macro ampere. It is coming 33 macro ampere, 100 ohms. So as you reduce the resistance, the current should increase, and the potential that your steel, which is electronegative, will become electropositive, and the copper, which is electropositive, will become the electronegative. So that is what we call the polarization. When once your corrosion cell is say formed, that is steel and copper. Okay, so this is now it is reducing that current at the 100 ohms, because it is say polarizing current is going on. So it's coming 28, 29. Now it is stable 28, 29 macro ampere. Now what we do, we measure the potential of the, so how the change in the potential. There will not be much change in the potential, and we see that this is the potential we measure same as we measured before. So it is coming. Yeah, steel, it has become 200 millivolt, from 380 to 200 millivolt. Okay, so that is in the positive direction, and copper, it is now again say 200 millivolt. Both is showing 200 millivolt. 200. No, its steel is a little more. So now it is increasing to 15 millivolt. So it is becoming more say electro-positive, you can say, and copper is now say 197, 198. So this is going to the from the electronegative side. Now we what we do, this is your resistor, this is the resistor. So we make it a 0 ohm. So now full current is going. So we see that here the current now it should increase actually, or moreover stable, because very less current is there. So I find that earlier it was say, now it's a minor increase in the current to 27, 28 macro ampere is there. So as there is a corrosion current, it will stabilize. Okay. So this current will be flowing. So what will be the difference now at this resistance? What will be your change in the potential? So that is again, let us measure the potential of the steel, which is coming now almost stable, 212 millivolt. So 380 to 212 millivolt. So from electronegative to electropositive, and the copper, which was earlier it was a positive, so now it has become 204, means electronegative side. So that the difference between the steel and the copper potential is a very less. That what we call it the corrosion potential. Okay. So this is how the polarization in a corrosion cell takes place. Okay. So next we will head to the next. We will break here. So now you have understood how the corrosion current flows in a different methods. Even in a pipeline also, you can have an anode and the cathode. So one will be more electronegative, slight difference. So the corrosion current will flow from the anode electronegative side to the electropositive side and back to the pipeline. So that is how the corrosion current flows. And in the next session, we will have that with the anode, we'll put now the sacrificial anode, zinc anode, and then we'll see how the polarization takes place with the sacrificial anode. So we'll continue this session about the polarization, then we will check the interference and other things by going to the practical understanding. Thank you for listening.